Hello and welcome to another Piper Pod. Today we're going to continue along with pathophysiology and we're going to look at the inflammatory process. When we talk about inflammation, it's a good place to start when starting to look at pathophysiology because inflammatory process is central to most disease processes. Obviously central to a lot of injury processes, but also diseases that occur have an aspect of inflammation associated with it. So when we talk about inflammation, we're talking about a very complex response that occurs as a result of tissue damage. Now it primarily involves all blood vessels, leukocytes and plasma proteins in its formation or in its journey. Now the main thing to think about when we talk about inflammation is it's not a standalone. So when we have inflammatory processes, it is entwined with our repair, our clotting, and in a lot of cases, very much linked to our histamine processes as well, to the extent you can very difficultly define the difference between a prostaglandin-based response or a histamine-based response. So just know that they're all very closely linked together, and during the presentation we'll be tapping into the repair. As far as the clotting process goes, we won't be looking too much into that today. Now the causes of inflammation, now whilst there are a huge amount of causes for inflammation, it can be broken down into infiltration of microorganisms, so it's bacteria, viruses, fungi, protozoas, all cause inflammation. Have an immunological response, so that can either be in the basis of an autoimmune disease or a allergy-based reaction. Tumours are classic for causing inflammatory reactions because obviously their formation is denoted as non-self cells, so it causes an inflammatory response. Now the exposure to certain chemicals, toxins and radiation also cause inflammation and are associated with quite a few inflammatory based diseases as well. So a lot of them. How popular in the culture today is the process of inflammation with foods and food intolerances and stuff like that. So that falls under the category of toxins because a lot of those food substances for certain people have an inflammatory based response that is outside the normal inflammation needed for digestion. So that's where the difference comes. So normal inflammation needed to produce digestive enzymes versus a toxin-based one, which is a more systemic inflammatory response. Now when we look at inflammation itself, what we oftenly associate with inflammation, and when we talk about it, is looking at just the acute stage of inflammation. Now this is where it's really quick onset, short duration, and it starts and most of the time ends with the infiltration of exudate. So that is fluid that contains leukocytes. So it's associated with leukocyte immigration. So if it's just fluids moving out, it's called transudate. If it contains leukocytes, then we move into exudate. So that's pretty much where acute inflammation stops. And you can test acute inflammation on yourself just by getting your fingernail and scratching a sensitive part of your skin, like under your arm, and then in a short amount of time you'll see a bright red line. Now where we start moving down into the chronic, now this often follows the acute phase. So an acute that starts off, but then the damage is too great, it goes on for too long, whatever it is, and it moves into the chronic. But chronic inflammation can occur just by itself as well. So you can just start the process with chronic inflammation in certain disease processes. So just keep that in mind. When we talk about the migration today, we'll be looking at acute moving into chronic. But just so you know, there are diseases out there that kick straight into the chronic inflammation side of the house. Now the difference in an overview, we'll go in more detail later, is it's a much slower onset and much longer duration. Now this particular one involves leukocytes as well, but two specific types of leukocytes. So we have our lymphocytes and our macrophages. The difference with acute is we usually only deal with our neutrophils associated with acute inflammation. We also have blood vessel proliferation, and the formation of fibrous-based tissue in repair. And because of the duration and types of cells, we also get tissue destruction. There are pathological differences with types of inflammation, and the way they're often defined is based on how they look and what is associated with mostly their healing factors as well. So as we go through inflammation, different types of proteins or different types of compounds will come out, and that usually means a different pathological form of inflammation is the result. So the first one is our serous one, and this is the one that just has a huge amount of effusion of clear fluids that looks like serum. So this is your clear serous fluid that comes out during inflammation, so therefore it's known as our serous inflammation. When we look at fibrinous, we're looking at exudate instead of serum. So where we start moving into that leukocyte infiltration. But in this case, we also have a large amount of fibrogen coming through the actual inflammatory process as well. Okay, so fibrogen is obviously associated with the clotting cascade, but when we have a fibrinous inflammation process, the fluid that's coming out is exudate, so high in leukocytes and also high in fibrogen. When it moves to plurulent, it's no longer exudate because we're dealing with leukocytes after phagocytosis has occurred. So once phagocytosis has occurred and we start to get a pussy formation coming through the inflammation, that is what's known as a plurulent inflammation. Ulcerative is obviously the form of an ulcer. Now the reason ulcers form is associated more with chronic inflammation and also wounds that have secondary intention. So what we would get is we get an ulcer forming inside, and then more times than not is the wound growing over the top. So internally we have an abscess or an ulcerative area, which is more like a deep cavity. When we start moving down into our pseudomembranous, this is where a false membrane is formed. So part of the healing process is obviously to form a membrane, but the purpose of the membrane is to encapsulate proper cellular structure. With pseudomembranous inflammation, we're dealing with abnormal cellular structure with a false membrane forming around it. It also happens when we form those abscesses. So a false membrane will form around an abscess, creating an inflammatory pocket or infectious tissue pocket around itself. Now, granulomatosis is a very special type of inflammation that forms granulomas. Now, granulomas are just a clump or a formation of granulation tissue. So these will often appear quite red, but red like a raised wound sort of red is when we start moving into granulomatosis as well. So just so you know that when we're looking at inflammation, there are different pathological forms that can result. Let's talk about the very first stages of inflammation. So when we first go into inflammation, the reason it occurs can be simply put as soon as you have epithelial or skin base, mostly cell damage, you're going to start the inflammatory response. Now, skin damage can be caused by obviously tissue destruction, but it can also be caused by internal infiltration of microbes, blunt force trauma, burns, anything like that. So anything that causes the cells of the body to be damaged causes an inflammatory process. That's pretty much as simply as it can be put. So once our cells, therefore our tissue, is damaged, those particular cells will release a bunch of vasoactive proteins. Now, the main vasoactive agent that is released is prostaglandin, but you also have a type of serotonin and cytokines as well that are released, and all of these things will cause a increase in capillary permeability and vasodilatory response. So they cause these vasodilatory responses. On top of that, they also send out chemicals that attract leukocytes to the area. The next thing that happens is leukocytes will come along and they'll move through the actual epithelial wall of the capillaries, a process called diapetes, and then they will move to the site of the cellular damage, all the bacteria or the broken structures, and they'll go through a process of phagocytosis following the chemical signals that have been released by the mediators in a process called chemotaxis. Once they get there, they'll go through phagocytosis and they'll start cleaning up and destroying the cellular destruction or the bacteria that's in place. So right there, that is the very simple process of what happens in acute inflammation, and this is what happens every time that any tissue in the body is damaged. Just to go into a lot more detail, we'll go through the flowchart of what's actually happening when we're dealing with inflammation, and we'll look at some of those cardinal signs and why they occur. So we'll start right at the top, which is with our tissue injury. Now, I've already mentioned that it releases our chemical mediators, and at the same time those chemical mediators will attract our leukocytes. Now, the first leukocyte to rock up to the scene is our neutrophils. So neutrophils are the most abundant leukocyte that we have, and they're the first ones to migrate to the area following this chemical signal that brings them along. Okay, now continuing along with what those leukocytes do is they'll move along the actual blood vessels, and then the cells in the blood actually do a very cool process where the red blood cells will actually line up with one another and stack like a stack of coins down the middle, so they can still function and allow more room for the leukocytes to move along the top of the capillary walls in diapetes and then move through the actual capillary walls themselves to be attracted to the area to start their phagocytosis. So that's what happens on the leukocyte side of the house. Now, as an additional result of these chemical mediators, we get vasodilation of the arterioles. Now, when this occurs, it occurs that it increases what's known as capillary hydrostatic pressure. It also opens up all of your capillary sphincters as well. So you may know or may not that capillary beds have the ability to bypass giving a lot of blood flow to that particular area just by turning off certain sphincters. Now, in the event of these chemical mediators, all those sphincters are turned on, resulting in the entire blood flow having to go through that whole area. So when we talk about vasodilatory actions, it doesn't actually cause the capillaries to grow in size because capillaries don't have any muscles. So what happens to the capillaries that make them more leaky is just a matter of having more blood flow supplied to those capillary beds and really slowing down that flow of blood. So obviously it has a greater surface area to travel, same amount of blood is going to move much slower, which results in a massive increase in hydrostatic pressure, which causes fluid to leak out. Now, as a result of this happening, our vasodilation causes temperature increase. Now, this is just a local temperature increase. It's not a fever at this stage. It's just a local area temperature increase because of greater blood flow to the surface. And because it's closer to the surface, you look red. The area looks red, and that's it. Now, the capillary leaking as a result of increased hydrostatic pressure does one or two things. The good thing is you're getting more blood flow to the area, which gives more nutrients and oxygen to the tissue that are starting to go through repair and cleanup. But as a side effect, we get a huge amount of fluid leaking into the area. So it starts as transudate, leaking in, but then anything that is not put back in, anything that doesn't get reabsorbed in the area, turns into oedema, and that is where our pain and our swelling comes from. So the pain side of the house is associated with a constriction of the stretch fibers that causes stimulus on the efferent nerve ending, and then also the swelling causes the pain when you try to move under restriction. Okay, and that's where our possible loss of movement comes from. So when you have inflammation in a small joint, then essentially you're going to have that possible loss of function. So it's not one of the cardinal ones, however it is often associated with it because of that. So once we have this process and it's gone through all of these steps, now I'm deliberately missing the clotting cascade because that's another topic if you're reading along. But once we get to this stage, we have a process where we have foreign bodies in the tissue as a result of either cells breaking or a result of infiltration from something, some sort of microorganism, that has resulted in phagocytosis occurring and an increase of the amount of fluid and proteins that are found in that particular area, causing an increase in local temperature, the appearance of red, pain, and swelling. Now, at this stage, we're at what's known as acute inflammation, and this is where most of the time we will pretty much stay. Complications from this is obviously we can increase and we'll have an increase in pus formation, so therefore more signs of an infection, and we can start to migrate towards a systemic fever, which we'll talk about later. But after all this area has occurred, at some stage we will start to move into the healing processes, which generally occurs after the inflammatory phase has finished, but it can start to occur pretty early, but it's not active until inflammation finishes, which can be around the 72-hour mark, just to let you know nice and early. Okay, so from the processes that we've talked about, we're at the stage of acute inflammation. So when we have acute inflammation, there's a series of options that can occur as a result of that inflammation. The first one, which is what we want, which is resolution. So as a result of this, the inflammation comes in, we just have our simple neutrophil coming in, our normal mediator proteins or chemical mediators will come through, we get our vascular changes, our dilation, our increased permeability, but then everything starts to clear up. There's a small amount of foreign body needs to be fixed. This is what happens when you scratch the underside of your arm. Small amount of foreign body needs to be fixed. Most of the cells go through repair, maybe regeneration, not too much, and then we return quickly back to normal function. Easy done. Another process that can occur as a result of healing is when we have a huge amount of exudate moving in. So when we start looking at our leukocytosis, where we have a large amount of leukocytes in the area. Now at this stage they're still just neutrophils, but there's so many of them that it starts to cause the formation of pus. Now when we get the pus, we have an increase in volume or substances that need to fit in that area, so it causes some form of damage. Now that damage will result in some form of fibrinous healing, and that's it. Okay, so certain degrees of fibrinous healing will occur, and a lot of the times when we have pus formation, we have an abscess that sits in there and will need to be broken down by the body or essentially removed by us realistically. But when we have healing, it often results in a fibrinous-based healing. Now the other option that can happen with acute inflammation is obviously it turn into chronic inflammation. Now this is where I'm not going to go into too much detail of the differences between chronic and acute inflammation, but it results in a lot more cellular destruction before it has to go through healing. Now the fundamental difference between chronic inflammation and acute inflammation often lies in the amount of tissue injury or tissue destruction that occurs. Now when we move into chronic inflammation, the healing processes often ends with some sort of fibrinous healing process. The main causes, generally speaking, now there are a lot more of pathological conditions that just jump straight into chronic inflammation, but true chronic inflammation is often caused by good viral infections like hepatitis B or C. We have immune-mediated ones, so any autoimmune disease that causes the body to attack itself, like Hashimoto's thyroiditis, and anything that is a prolonged allergy-based disorder like our asthma. What is also common with our chronic inflammatory conditions is that constant prolonged exposure to certain toxins or certain irritants within the body. Now, we've all heard of asbestos, we've all heard of cold disorders, things like that, but it could be boiling down to like any industry dust that you're breathing in, anything that is composite fiber-based tissue, not tissue, but substance that you're breathing in is going to cause a form of lung disease. So you may be asking yourself, what is the responsible agent in causing all these problems to change from acute to chronic problems? Now, it is obviously a time factor, but the main variables that cause a problem in changing from a nice acute inflammation that can be fixed up easy, resulting in small amount of tissue damage, to a chronic problem that often has complications, has got to do with the type of leukocytes that are involved. Now, the type of leukocytes that come in after a period of time of inflammatory response needed to occur are your macrophages and your special types of lymphocytes. The main ones being the T lymphocytes and the cytotoxic T cells. So these two particular leukocytes will come in and they will start going through massive phagocytosis at the expense of causing more tissue destruction. So these two particular ones will go through and they will just destroy all foreign bodies, cause more tissue destruction, which will activate more, and we'll start our cell-mediated immune response on the area, and we get a prolonged and more damaging version of inflammation. Now, as a result, this results in needing vascular repair. Okay, so angiogenesis needs to occur, so vascularity needs to be rebuilt, tissue needs to be remodeling, and it often results in a need for secondary indication healing. And as a result of that, we also have the release of pyrogens. Now, these two types of leukocytes are the only leukocytes that can release pyrogens. And what pyrogens do is they increase thermoregulatory monitoring of your hypothalamus. So what I mean by that is if your hypothalamus is set to 37, no, it's usually 38, but anyway, set to that, then you get pyrogen release from these two particular leukocytes, then it's going to be increased. And the more pyrogens that are released as a result of these two leukocytes and going through phagocytosis, you're going to have a much higher temperature each time. So the longer it goes on, the higher the fever is going to be, and that is when your true fever will kick in as a result of inflammation/infection. Okay, so these two are the ones to blame when we're looking at chronic inflammation. When all is said and done, the body needs to heal itself. So this will continue varying degrees. So macrophage formation won't actually begin to occur until about the 12-hour mark, but mostly when we start looking at the chronic side of the house, it's got to do with macrophagic involvement at the 48-hour plus mark. But once it is all done, and at some point in time, once inflammation dies down, we're going to start moving into healing. Now, when we look at healing, it's a mixture of regeneration and repair. Now, what happens in the body depends on the type of cell formation that has been damaged in that particular tissue. So there's really three different types of cell formation that occur in the body. There's one that is continuously dividing cells. Now, these are classically found in the skin and the liver, things like that. So whenever one of those areas are damaged, that cell's structure, that tissue structure, is able to go through mitosis and rebuild itself perfectly. Easy done. Now, when we have the type of cells, so the quintessent fluctuative mitotic cells, which is a very fancy way of saying cells that will divide, but only under perfect conditions. When it has to go through repair, that is when it is replaced with some form of fibrinous network. So regeneration is mitosis, repair is being replaced with some sort of fibrinous network like scar tissue. Then we have a third type of cells that will not go through it. So they're the non-dividing post-mitotic cells. So our neural cells are classic examples. Once they've grown and they've been put in place, then they're not going to go through mitosis. Okay, they're very long, very complex. They're not going to go through mitosis. They're going to rely on the repair side of the house, which means you're going to get scar tissue. Now, another thing that it will depend on is how much of the initial tissue framework is still in place. Now, the reason that's important is if you have certain wounds on the skin, even though they're continuously dividing cells, you're not going to be able to get regeneration because a framework, what's known as keloid lining, has been destroyed too great that it cannot actually regenerate itself, and it will have to result in a fibrous network being produced. So the stages of cutaneous wound healing, so this is our simple side of the house. We've already gone through the first two, which is our hemostasis and then our inflammation stage, and then we start moving into our proliferative phase. Now, as you can see, it's days or weeks later. This is where we start to get our fibroblast formation, our granulating tissue starts to form, we start to get epithelial growth on the top, angiogenesis occurs, which is where our blood network begins to rebuild itself, and we start to reorganize our cell structure. Once that is done and we start to get a little bit of strength, then we move into our remodeling. And this is where we fine-tune things. You know, we add our tensile strength to the wound, we have our fibrous bonds connecting between the cells called desmosomes, and everything starts to heal over. Now, if it's happened beautifully, we won't be able to tell much of a difference. Okay, it'll be a nice, easy little scar. If it hasn't, then we need to rely on other sorts of tissue to move in order to elicit that healing response. Now, when we talk about that, that's when we start to bring in primary intention versus secondary intention. So when we look at primary intention of healing, it's what we've just spoken about. The 24-hour mark, we've got that hemostasis occurred, clotting's kicked in, inflammation is going. Inflammation is not that great, so we don't have to have any more leukocytic infiltration or migration coming in. Okay, we might have a little bit of macrophagic reaction, but not much. At the weak side of the house, that's when we start to get our angiogenesis, our vessels start to rebuild and form themselves, and we have a small amount of fibrous tissue at the base just to help hold it together. Okay, so a wound is never the same again. So whatever wound you have, it's going to have a slight involvement in a fibrous network every single time. But when we have a wound that has to rely on secondary intention, this is when we are resulting in either some form of wound delay, for reasons that we'll talk about, or a large surface area that has been damaged, which means we can't actually have that remodeling or proliferation occurring because of the surface area variables. Can't be done. Okay, so there's so much area that can pick up foreign bodies that our initial inflammatory phase of phagocytosis will just keep continuing until the body goes, you know what, I'm just going to put a cap on it. And then they put an epithelial cap of fibrous tissue over the top, and then they start to grow fibrinous tissue or scar tissue around it in order to create some form of barrier to the rest of the body, knowing full well that it's not proper cellular structure. Okay, so that's our secondary intention of wound healing. Now, things that determine that, and the things that determine which one we're going to go for, is our site and our size of the wound. So large wounds, no choice. Okay, they're going to have to be secondary intention because they're just too big. Now, certain sites, often associated with complex tissues or a lot of movements. Okay, when you have an area that has a lot of movement, you're not likely going to be able to get primary intention. Now, that also comes down to mechanical factors. Okay, if you're moving a joint too much, it's not going to work. The presence of an infection is always going to delay healing and often result in secondary intention. And then we have to look at our patient as well. So our patient factors really plays a big role, and the main one of those that is a variable for all is our circulation. Okay, so this is why people will often tell smokers not to smoke when they are healing wounds, okay, because smoking will temporarily reduce the circulation to the area and play a big role in the healing properties that need to occur. Now obviously if they're not getting enough food on board to repair the tissue or regrow the tissue, regenerate it, it's not going to happen. Okay, and the same as age, because they have their epithelial structures, okay, their skin structures, they're not as robust, they're not as flexible as a young person, so it often results in delayed healing and then also scarring as well. Now further complications that can occur is dehiscence. Now we all know that is where the wound has, for lack of a better term, moved apart from itself. So there is no nice closing of the wound, which means they're going to have to result in some form of fibrinous growth, which is which is secondary intentions that gives you a larger scar and a weaker heel. Now keloid scarring is something that occurs in a small percentage of the population. So what is often denoted as keloid scarring is just hypertrophic scar tissue. So a large amount of scar tissue that looks quite nasty, for lack of a better term, I can't think of the word, but it doesn't look appealing. It is not nice looking skin, and that's essentially what keloid scarring looks like as well. So people that suffer from keloid scarring will often get large scar-based wounds, even from the smallest ones. Now when you have a really difficult wound and one that will not close and it can't rely on simple scar tissue, then you will have some aspect of keloid formation. Okay, but it's a complication. Now contractures is something that happens in every wound. Okay, so when a wound is healing, even with primary intentions, you do get the fibrous network forming underneath the skin, and what they do is they actually contract. So they produce contractures on themselves, and that helps hold that area of the skin together, so then you can't come along and just reopen it. So that is normal contractures. When it moves into a complication, it's when it's of an area that involves a lot of movement. It's quite classically the fingers. So contractures mean that as the wounds on the hands or the inflammatory response on the hand is healed, you'll actually have a reduction in the range of movement, as a result of contraction. So a large amount of fibrous tissue pulling at opposing ends, causing the fingers to contract down onto themselves. Okay, so that's a complication called contractures. Okay, so that is the entire inflammatory response and a small introduction to the healing process that we'll go through. A good way to start is inflammatory processes, because then when we start talking about our diseases, most of them are going to involve some form of inflammatory process that we can draw back to this lesson in order to have a better understanding. Until next time, take care.